All right, guys, everyone got a copy? All right, we're ready to roll. So what we see here in front, we're going to derive our derivatives for sinusoidal functions or trig functions. We actually kind of already done this one. We did do a formal definition, but we didn't know at the time. I don't know if you remember your notes from quiz 5, UH quiz 5, trig limits. The very, very last one where it said like find C is pi over 6 and f of x equals 5 cosine x. Find limit as h approaches 0 of f of x plus h minus f of x over h. That was the definition of how do you find the derivative of sine or cosine. If you want me to do it again, no big deal, we'll do it again. So what you have here in front is a sine graph. And what we're going to do, we're going to look at tangent slopes. Notice that wherever this sine graph has a max or a min, you have a tangent slope of, or you have a slope of 0. You guys notice that, guys? And then notice wherever you have your point of inflection, which is where it crosses the x-axis, you either have a slope of positive 1 or negative 1. Because it makes a 45-degree angle with your xy plane. Are we okay with that? So if we were to plot the derivative, the slope value, and I'm going to change my color to blue. So wherever I have 0 slopes, I'm literally going to put a point at 0 for the y value. Just keep the x value the same. So at that value, there it is. And wherever I have a slope of 1, I'm going to go and plot a point at y equals 1 with that same x value. Slope of 0. Yeah. The slope on my point of inflections have values of positive 1 or negative 1. So I went to the same x value and plotted the y value slope, the y slope value. And I'm going to do the same thing at this one, the negative 1. And then I probably should change the grid to give me, instead of integers, to put it in terms of like pi over 2, pi, 3 pi over 2, and all that good stuff. So my bad, guys. And if you were to plot those points, notice that you have a function who's also sinusoidal. What does that look like? Yeah. So we can make a statement from there, guys, that the derivative of sine x is cosine x. Do you guys want me to do the limit process? I mean, it won't take too long, maybe a minute or two. But if you guys don't want to, that's fine.
I think we should see it.
Okay. So if I told you that f of x is sine x, because it is, and I told you I want you to find f prime of x, the old way would have been to do this. Limit as h approaches 0, sine x plus h minus sine x all over h. And we're going to need a composite argument property for sine a minus b, or sine a plus b, sorry. So on the top, I'm going to write, I need this guy, sine a plus b. Do you guys remember what that composite argument property looks like?
Yes.
What is it?
A cosine B plus
Yeah.
cosine A cosine
So, following that rule, I'm just going to plug in, guys. I'm going to write limit as h approaches 0, and let's see if I've got space here. Sine x cosine h plus cosine x sine h minus sine x all over h. How do we feel so far, guys? All right. All I'm going to do, I'm going to switch these two here. Now, there's no equal sign, so you got to keep the sign, because we're not moving it to any, like, we're not moving it to, like, the other side of an equal sign. So you got to keep the sign. So here's what I have. Limit as h approaches 0. And I still have this sine x cosine h, but now I'm going to write minus sine x and then plus cosine x sine h. All this is over h. We're still okay? All right. And then I'm going to focus on these two here. I'm going to factor out sine x. So here we go. Let me see. I'll do it right here on the bottom. Limit as h approaches 0, sine x factored out, cosine h minus 1, all over h. And can I break this up and do this? Is that okay if I do that, guys? Yeah. Is everyone okay? All right. I want you to realize, I'm going to put the equal sign here. Notice I'm not going to write the word limit. I want you to see that I have cosine h minus 1 over h as h is approaching 0. This sine x is not affected because there is no h on it. So I have sine x. We'll go back to red. And what is this cosine h minus 1 over h as h approaches 0? Do you guys remember? It's not 1. It's 0. And then plus, this cosine x is not affected because this doesn't have an h, but look at that right there. So, so I have plus cosine x. And then what is sine h over h as h approaches 0? 1. So I have 0 plus cosine x. So finally, f prime of x is just equal to cosine x. And there it is. We did a derivative. My derivative of sine x is cosine x. Are you going to have to do that all the time? No. Just remember, what's the derivative of sine x? There it is. You already have it memorized. Say it 3 times. Cool or not cool? I hear that 3 is the magic number. I remember reading a book about memory, and the book literally said, do a task 3 times, and you will remember. I need to figure out what book that was. Maybe I should have read that book 3 times. All right, so there it is. Here's what we just derived. The derivative of sine x equals cosine x. There you go. Take a guess. What do you think the derivative of cosine x is? Almost. There's a negative in the front. There's an easy way to remember this. You want to hear the easiest way to remember whether it's positive or negative? You're not going to read this in a math book, but I'll tell you. If it starts with a C, if it's a trig identity that starts with a C, and there's a whole bunch, cosine, cosecant, cotangent. If it starts with a C, the derivative is negative. Cool or not cool? All right. If it starts with a C, the derivative is negative. So there you go. So the derivative of cosine is negative sign. The derivative of cosine is
Negative sign.
one more time. The derivative of cosine is
Negative sign.
there you go. All right, here we go. Let's test to see if we can figure this out. It says find the derivatives for the following functions. I see a function, and I see it, and I'm like, oh, I got to take a derivative. I recognize that I have to do what rule? Product rule. Underline the first, and I'm going to double underline the second. So wherever you see a 1 line, that's my first. Wherever you see a 2 line, that's my second. So here we go. The derivative is first, x squared, times the derivative of the second. What's the derivative of sine x? Cosine x. Plus the second, sine x, times the derivative of the first. What's the derivative of x squared? 2x. I think on delta, they let you keep it like that. Let's start to simplify stuff if we can. Usually you want your variables in the front. X squared cosine x plus 2x sine x. A common mistake, and you guys won't do this, I hope, is that you guys tend to mess with the argument of your trig. You can't do anything about that argument. It stays alone. Leave it alone. Like you add an extra power or something and leave it. It's by itself. It's sine of x. It's cosine of x. Any questions right now, guys? And there it is. That's it. Look at letter B. What rule do I got to use? Quotient. I'm going to write y prime. Do you guys remember the quotient rule? Low d high minus high d low over low low. So bottom, low d high, times the derivative of the top. What's the derivative of cosine x? Positive or negative? It starts with a c, negative sine x. Plus or minus? Minus, the quotient rule is a minus, minus the top, cosine x, times derivative of the bottom. Now, because there's a negative in front of the sine x, it's going to keep that sign. So, everyone okay? The derivative of 1 is 0. Yes. All over. Yeah. Catch up to there. Are we okay? Okay, so maybe delta allowed this much, but now let's simplify. So I'm going to distribute. So let's see. It looks like there might be a property here that we can use. Negative sine x plus sine squared x plus cosine squared x. Notice where I put the square. If you don't put the square after the end, then put parentheses on it and then put the square on the outside. Do not put the square after the x. All over 1 minus sine x squared. Are you guys still okay?
Where did the one? Oh, never mind.
And then hopefully there's something staring at you that you should be like, I should change it, I should change it, I should change it. We see a Valentine's formula. That's not the official name. So when you go to the university, don't call it that. Your professor's going to give you a weird look. Well, I mean, I don't know. Maybe he'll be like, I like that Valentine formula. Negative sine x plus 1 over 1 minus sine x, close it, squared. And still, okay, well, I'll wait for you guys to catch up. Hopefully, your heart of heart is telling you, wait, there's something more that I can do. Notice that in the top you have a negative sine x plus 1. And notice that in the bottom you have a 1 minus sine x. If I rearrange it, we're not moving anything, we're just rearranging it. If I rearrange it, is there something I can cancel? Yes. A whole 1 minus sine x. Do you guys see that?
Yep.
So now what you're left with is that. So here's an example where algebra was definitely required. What's up, miss?
Did you switch the top one?
I just moved the 1 to the front and moved the sine x to the back. Yeah.
Would you be expected to move to make the 1 over 1 minus sine x into like cosecant x?
No, there is nothing you can do with that. Now, if it was 1 minus sine x, no, there's nothing you can do. You can't change it from there.
How do you get from the 1 over minus sine x over 1 minus sine? How do you do that?
Oh, I canceled that with one of those.
Oh,
You know what I mean?
wait, why is it? Wait, how do you still end up with 1 minus sine x? Because wouldn't it be 1 plus sine x if you're doing a different square?
There's not difference of squares. I have 1 minus sine x times 1 minus sine x on the bottom.
Oh, right.
I have 2 of them, and I just canceled 1. Laws of exponents. You know what I mean? Okay. You guys okay over there? All right. Notice, guys, the only calculus was in the top line with the rule, and even the rules are not supposed to be hard. They're just rules. You're just applying the rule. Well, it's just like saying in English, like, what's the definition of a word? All you're doing is applying it. That's it. So if you can apply it, you're good. Cool or not cool? All right, let's keep going. Now, it says here that we're going to derive tangent. So we're going to derive it from scratch, but from now, after we do this one time, you're never going to derive tangent from scratch. So let's see. I'm going to write d dx because I'm not evaluating it just yet. D dx, and I'm going to turn tan x into sine over cosine, right? So sine x over cosine x. So there it is. I haven't evaluated anything yet. I just rewrote what tan is. And because I have something over something, what rule can I use? Quotient. So now I'm going to be taking derivatives, so I'm no longer going to be writing d dx, because that is a derivative. So bottom, cosine x, low d high, times the derivative of the top. What's the derivative of sine x? Cosine x. Plus or minus? Minus top times the derivative of the bottom. Perfect. All over what? Sine x or cosine x? Cosine x. Bottom squared, guys. Low, low. Low d high minus high d low over low, low. Are we okay so far? All right. So now let's see what we get. Equals, I see cosine squared x, and the negative times the negative is a positive. So it's looking like I'm going to be able to, once again, use the property. Cosine squared plus sine squared is equal to, so 1 over cosine squared. And maybe, I guess technically you could leave it like that. But 1 over cosine is the same thing as, so, and because this is squared, that means, do you think you have to do this all the time, every time? No, just memorize it. What's the derivative of tan x? Secant squared x. What's the derivative of tan x? What's the derivative of tan x? Okay, good. 3 times. We're saying it 3 times every time. So now, here is the list of the derivatives that we must know stone cold. Can we derive them from scratch? Yes, we can. We can derive every single one of them from scratch. Chavez, how? I don't know how to derive secant x from scratch. Rewrite it as 1 over cosine x, and then you can do quotient rule, and you'll see that you'll get that guy. I don't know how to do cosecant, the derivative of that. Yeah, you do. Rewrite it as 1 over sine x, and do quotient rule again, and you'll see that when you do quotient rule, you'll end up with that guy. Chavez, you're asking way too much. I have to memorize way too much. No, you only have to memorize really sine and cosine, virtual easy, and 2 of them. Let me show you. Let your brain, guys, you guys have a really big brain that can do a lot, but don't make your brain work harder. Make your brain work smarter. This is how you do it. The derivative of tan is secant squared. Derivative of cotangent is negative cosecant squared. Okay, these are the 2 that you got to memorize. Derivative of tan is secant squared. Derivative of secant x is secant x tan x. If you memorize those 2, you can theorize what the other derivatives are. How? Well, if the derivative of tan is secant squared, cotangent and tangent are related. They're reciprocals of each other, right? So I've already used up secant squared. What's the other reciprocal that I have not used? Cosecant squared. So, and remember I told you if they start with a c that the derivative is negative? So look, derivative of tan is secant squared, derivative of cotangent, negative cosecant squared. What about the other one? Well, look at this one. Derivative of secant x is itself and add a tan x. Secant x tan x. What about cosecant? It's related. Look at this. If you already used up secant, you haven't used cosecant. If you already used up tan, you haven't used a cotangent. This one starts with a c, so you put a what in the front? Negative. See, do you see how easy it is to memorize if you are smart about it, about how to structure your brain? Yeah. The derivative of tan is secant squared. What's the derivative of secant x? Yeah, that's it, guys. What's the derivative of secant x? Secant x tan x. What's the derivative of secant x? Secant x tan x. What's the derivative of secant x? Secant x tan x. Before you know it, you're going to be like, oh yeah, the derivative of secant x is secant x tan x. Cool or not cool?
Cool. My brain is a little bit glazing over.
Yeah. Don't worry. So look.
Have no meaning anymore.
So now check it out. So if someone asks you culture, and relax. Look, we've only introduced it. We've only been talking about this for 1 minute, and you already know what the derivative of secant x is. What is it? Secant x tan x. So someone says, all right. So now someone comes with a curveball and says, all right, hotshot, what's the derivative of cosecant x? And you're like, oh wait, I didn't know that. Yeah. So. Yeah, there you go. You start thinking and you're like, wait a minute. Well, the derivative of secant x is secant x tan x. So cosecant x is similar. Negative. Secant x, I already used up that. Oh, it has to be cosecant. And it has to be cotangent. Negative cosecant x cotangent. Do you see how we're doing it? Yeah. So remember, train your brain because you want your brain to work smarter. I mean, can you memorize this? Yes. But really, the only 2 you have to memorize are these 2. You memorize those 2, and then the other just know they're related. Oh, okay, what have I not used up? Oh, okay, I haven't used those. So it must be that. Or just memorize it. whatever you think is easier. How do you feel, Miss Irela? You got this? Okay. Example 2 requires a calculator. Let's not do that one yet. Let's do example 3. What do they want me to find? The second derivative. So here we go. First, find my first derivative. Y prime is equal to, what's the derivative of secant x? There you go. See, when you go home today and your parents tell you, what did you learn? I'm like, well, I know the derivative of secant x. Secant x tan x. All right. Now, I'm going to find a second derivative because that's what they told me to do. What rule am I going to have to use? Product rule. Underline the first, double underline the second. So here we go. First, secant x times derivative of the second. What's the derivative of tan x? Secant squared x. Plus the second, tan x, times derivative of the first. What's the derivative of secant x? Secant x tan x. Now we're just going to make it pretty. This is all a product, right? Y prime prime equals secant x times secant squared. That's going to be secant to the third. Put the 3 after the c. Plus tan x times secant x times tan x. So how many tans do I have? Perfect. There it is. I would leave it alone right there. Done. We feel okay? Ask. I got answers, hopefully. Are you talking about right here, this one?
I'm talking about the second part of the equation after the plus sign.
Oh, okay. First times derivative of the second plus second times derivative of the first. The derivative of secant x is secant x tan x.
Right, okay, I got that.
And then, so I did first times derivative of the second. So derivative of tan was secant squared plus second. So this tan x is that. And then the derivative of secant x is secant x tan x. And there it is. So, and then this is all a product. So tan squared secant x. All right. Here we go. Example 2. This will be the last one we do, guys. It says, find equations for the lines that are tangent and normal to the graph of f of x equals tan x over x at x equals 2. So we're going to use a calculator to figure out that y value. So take out your calculator so we can all, and I don't know if I should show you yet how to use a calculator to take a derivative. Maybe we will, maybe we won't. I don't know. We'll see. I'm going to see if I can order some calculators. I need to get a charging dock first. But all right, so here we go. If I want a tangent line, I need two things. I need what and what? A point and a slope. So let's get our point. So my point is 2 comma, and I guess not fun way, tan 2 over 2. But I want to give me a decimal, so let's figure out what this is. 2 comma. So I take my calculator out, and first I got to tell my calculator to be in radian mode because it says degree there. Mode, radian, always radian. Okay, now I'm in radian mode. So in the mode, and then it should be, if you toggle down, you'll see radian or degree. All right, here we go. What was it? Tan 2 divided by 2? So there it is. At least 3 digits after the decimal, but you know what? Let's put 4. Negative 1.0925. Negative 1.0925. Did everyone get that? All right, here we go. Now I'm gonna find the derivative. Y prime. So first, what rule do I gotta use? Quotient. I'm forced to use quotient. There's nothing else I can do, guys. You have to use quotient. Bottom times derivative of the top. What's the derivative of tan? Secant squared x. Plus or minus? Minus top times derivative of the bottom. all over bottom squared. Chavez, my calculator doesn't have a secant button. Relax. Here we go. I'm going to just fix it. So I'm going to make it look pretty. X secant squared x minus tan x over x squared. I guess it doesn't really look much different. And here we go. Y prime evaluated at 2 is equal to 2 times. Now my calculator does not have a secant squared button, so I'm going to have to write it like this. 1 over cosine 2 close all that squared. Did everyone see how I got that? Because remember, secant is the reciprocal of cosine, right? Okay, and then don't worry, I will probably show you how to tell the calculator to just give you the derivative immediately. Tan of 2 all over 2 squared. And we're going to see what that number is. What's up?
Did you plug in the 2 into the derivative?
Yes, I've just plugged in a 2 into my derivative. So here's my calculator. So let's see. 2 times parenthesis, and it was 1 divided by cosine of 2 close, and then close again, and square it. So I'm doing my numerator. See? And then I already forgot, did I have plus or minus? Minus, and was it tan 2? Tan 2. So this is my numerator. I just did it in one line. I'm going to go ahead and push enter. And I'm going to divide that by what?
4.
By 4? 2 squared, right? So I got 3.43345, or 46. 3.4334. You know what, truncate. Let's round it. 3.4235. 3.4335. Is everyone okay so far? All right. What's my tangent line? Do I? Yeah. Y plus, let me zoom out, 1.0925 equals 3.4335 parenthesis x minus 2. Yeah, it looks nasty. No, the 2 was positive, right? X minus 2. It's x minus x1. And don't worry, we're going to use technology to see how our tangent. I know it wants the normal too. We'll give the normal in a little bit, but I want to see it. So I'm going to go to Desmos. Desmos. DSMOS. Hey. All right, here we go. Hook me up with the equation. What was it? Y equals tan x. Tan x. Oh man, look how it looks. So that's how my graph looks. Now let's check out our tangent line. What was it? Y plus 1.0. Don't worry, it's coming back up. 1.0925 equals 4335. Yep, that definitely looks tangent right there at 2. Look at that. Cool, right? Now, let's see if we can do the normal real quick. Chavez, we can do it real quick right here. So I'm going to do the same thing. It's the same points, right? Y plus 1.0925 equals, now how is my normal and tangent related? Opposite reciprocal. So let's put a negative. 1 over 3. Don't worry, I'll come back, right, guys? 4335. It does that when it starts getting warm, because the laptop is burning up right now because we're using it pretty hard, because not only are we doing stuff, we're recording as well. X minus 2. And look at that. That definitely looks like a normal. And that normal and tangent, and I know, I'm sorry guys. Look at that. If I zoom in, yep, that's a tangent, and that looks like a normal. Cool, right? Or you guys don't think that's cool?
No, that's
All right, guys. Yeah, you can. You can do it on.
What if you like, can you press something on the calculator to make it like straighten it or
Yes, you can.